go. So first off, when you sketched these, we're going to be talking about what they look like when they intersect. And some of these circles did intersect each other, so it'll give us a good chance to talk about that. So today's lesson is about polar equations and intersections. All right, so if you were going to graph that first one, I hope you remembered that sine was generally up here, and that cosine is generally over here. And then one of them was 2 sine, so I'll use black again for that one, and it's basically just going to go out twice as far in that direction. And last but not least, r equals 4. Well, that's pretty simple. It's just a circle with a radius of 4. But what I'm hoping you knew is that that would be way out and bigger than all of these, and it wouldn't have touched any of them. Does that make sense to you? This one, the 2 sine theta one, that distance right there is 2. Okay. You might think that the radius is 2 on that. It's not. 2 sine theta does not have a radius of 2. All right, so this does have 2 circles that are kind of nice. They're about the same size, and they do touch each other. Do you see right there? We have an intersection between this one, which was sine of theta, and this one, which would have been cosine of theta. And where did they intersect? Would you agree that kind of looks like it's about at a 45-degree angle? And if it's really 2 circles, where they are, that's at a 45-degree angle. So this is the point something comma pi over 4. What's another place that they intersect? Well, right back here. I'm going to erase out the ones we're not talking about here. We weren't talking about that circle. And we weren't talking about the green circle, but I guess that's far enough away that I don't think you'll be distracted by it. So what's that spot? Well, it's 0, 0. It's just not what you used to think as 0, 0. Because these are always r's, thetas. And it's saying the radius of 0 at the angle 0. Why is that not normal 0, 0? Because do you get that if you had r theta and it was 0, anything, it would still be at the origin? If it has a radius of 0, it's at the origin. So when you're in polar, 0, 0 isn't just 0, 0. 0, pi over 2 would also be there. If the r is 0, it's there. All right. So one thing you could do if you wanted to find the intersection point would be make a big list of all the points that are on sine and all the points that are on cosine. And do you get eventually, you'd be like, oh, there's one that's on both. You know what I mean? Well, what would the angle be that's in common? If I was making a big r theta list, what would be the angle that they would both be at? Come on, you guys, this isn't that hard. What's the angle? Pi over 4. They would both be at pi over 4. Would you all figure out what sine is there and what cosine is there? I think this will help you understand what intersection points mean. If they both share that same exact point, then all right. And if you're having trouble with this, like, it's because I know we're in polar, but yet we're harking back to circle trig. And so I'm supposed to try to figure out what pi over 4 is. I'm just going to draw myself the triangle. I really feel that's going to help. This is pi over 4. It's also 45 degrees. And that reminds me, oh, 1 square root of 2. You know what I mean? All right. So what's the cosine of pi over 4? 1 over root 2. What's the sine of that same exact pi over 4? 1 over root 2. That is the intersection point. 1 over root 2, comma, pi over 4. Notice, it's a point. In polar, you need both. You can't just have an angle. You have to have an r and a theta. So that point and that point, they're on both equations. So that's a shared point. That's the spot. The other one would be 0, 0. If I put in a 0 for the angle, would they both come out to it? No. That was unexpected. Here's the way you'd find those. Here's where 0 is for an angle. The angle 0 is there. It's at 1, 0. Which of them is actually 0? Sine of 0 is the y, which is 0. Good. 0, 0. Sweet. Wait a minute. This one's not 0, 0? Nope. What's the cosine of 0? It's 1. 1, 0. You lied to us, Mr. Server. They don't touch at 0, 0. Yeah, they do. What's the angle on cosine where you'd get a radius of 0? Yes?
0.
Pi over 2. Let's look at pi over 2. It's right here. At that spot, 0, 1. Sine is the y. Uh-oh. Y is 1 at pi over 2. So that didn't work. Yes, sir? Oh, cosine. Cosine is the x. You're right. And x is 0. Okay, you were doing cosine there. Cosine is 0 at pi over 2. So that's 0, pi over 2. These 2 points are the same. I know that feels weird, but they are. You know how they're both at 0, 0 on the graph? Having a radius of 0 puts you at the origin, and this is also at the origin. And so I know that's kind of a brain melt there. That 0, 0 and 0, pi over 2 are in the same spot. Okay, so those are your 2 answers for that intersection. That's a typical one for today. Go on. If you can't do these, you're going to be cooked when we do the graphs. Because you're going to have an r and a theta, and they're going to say like, okay, theta is 0, theta is 3 pi over 2, and theta is 7 pi over 6. And I'm going to change this to cosine because it just was too confusing. A lot of kids didn't even catch that they changed to sine in the middle. We're going to find cosine of these 3 things. 0, 3 pi over 2, and 7 pi over 6. Making me check myself in. All right. We're doing cosine of 0. Here's where 0 is. 1, 0. Cosine of 0 is the x of it, so that would be 1. Raise your hand if you got 1 there. Okay, good. The next one, 3 pi over 2. That's here. So that's the point 0, 1. Clem, can you tell me what the cosine of 3 pi over 2 is? It would be 0. Remember, that's just like 0, 0. I mean, because it goes through the same spot. Any radius of 0, it's just the origin. Okay, and then the third spot. This is the one that I was really afraid a lot of people would mess up on if they didn't draw it. So did you draw it? How many of you actually made a little picture like this? Raise your hand if you made a picture. Okay, we'll see if there's any correlation between the people that made the picture and people who mess up on it. This is 30. 30, 60, 90. 1, 2, square root of 3. -1, negative square root of 3. And therefore, cosine is adjacent over hypotenuse. It's negative root 3 over 2. Raise your hand if you had that one right. Okay, didn't fool many people on the negative. But if you forgot the negative, I bet there's a strong correlation, as in like maybe it's half the people who forgot the negative were the ones who didn't make the picture. Because making the picture is what helps you remember that. All right. Now, how big is that? If you had to actually graph that, what the heck is square root of 3 over 2? Well, what's the square root of 3? I told you to memorize it. I told you to memorize square root of 3 and square root of 2. Who knows what the two numbers are? Raise your hand if you got both of them. And like a steel trap. Samik.
Square root of 3 is 1.7.
The other one?
1.4.
You are correct, sir. And keep those memorized because if you were right now asked to figure this out and graph it on a test, you'd be like, where am I supposed to put, okay, if I only knew what square root of 3 was. Oh, it's 1.7. Do you get that 1.7? This really comes down to negative 1.7 over 2. Well, do you get that's pretty darn close to 2 over 2? 1.7 is pretty close to 2, isn't it? If it was 2 over 2, this would be negative 1. Would you agree it's a little less than that? So like maybe 0.8 or something like that? You could be off that much? Yeah, you're just putting a dot on a graph. You know what I mean? How am I supposed to tell whether it's 0.8 or 0.7 or 0.6? I mean, I won't be able to tell on your dot because you can't be that accurate anyways. But if you're trying to graph root 3 over 2 and don't have any guideline that, oh, square root of 3 is actually 1.7, you'll be toast. All right. Next. This is like a lot of hard work. What would have started first if they had said graph this on the test? What would be the first thing you would have had to do? If they tell you to graph 6 cosine theta, Wilson, what would you have to do first?
I'm not really sure what you're asking. So.
Okay, fair enough. Let's say all of this was blank. And they just said, here's a chart, graph r equals 6 cosine theta. What would be your first thing you'd do?
Would I graph cosine theta?
Yeah, well, yes, kind of. But yeah, I know it's a 6 in front of cosine, and so therefore fundamentally it's just a cosine graph. Would you agree that it's probably kind of over here? Okay. And then that 6 makes it what?
Stretch out to 6.
Okay. But how do you get exact points? You know it's a circle on the right, and it's bigger than normal. How do you get exact points?
By plugging theta into the equation.
But what if they don't give you any thetas?
Just put down like 0.
Try something like 0. And they chose these. They chose a bunch of pi over 4s. 5 pi over 4, that's really 6 pi over 4, 7 pi over 4, and 8 pi over 4. They went with the pi over 4 theme. Okay, so you just pick a bunch of angles and then you figure out 6 cosine of that. Which really is find cosine of them and then times it by 6. All right, so that's just a reminder of how you graph. One kid had asked just perfectly, right before I hit advance to the next slide, they asked, are they always circles? No, they aren't always circles. It was like, oh my gosh, they're psychic. So look at how, if we have one where this sort of looks like a circle and a heart had a baby. It's like a cross between a circle and a heart. All right. And that has a name. It's called a cardioid. Have you heard of cardiac arrest? So cardioid The root word in there, I think, is a Latin word that probably means heart. All right, so anyway, a cardioid has some number in front of cosine or some number in front of sine and a number either plus or minus that. So like for instance, do you remember this one from yesterday's homework? 2 minus 2 cosine theta, something like that. It was either cosine or sine. And did you notice that it was one of these kind? If you just assumed they were all circles, you might have got this dot, this dot, this dot, this dot, this dot, and thought, oh, it's a circle. I'll just connect the dots in a circle. And you might not have even noticed the little party side to it, the cardioid part. How are you supposed to know that on a test? You're supposed to know if it looks like this, that it isn't a perfect circle. What if it was just this? Then it would be a perfect circle. It's the thing in front of it. If there was like a 7 minus that, whatever number minus or plus this, that turns it into a cardioid. They can look like this too. See, same thing. And then they can even look like this. They can have a loop on them. All depends on what numbers you pick for A and B. See how it's just like the other ones, except it's got this loop? Okay, that's called a limicon. Don't worry, you're not going to be tested on those names. All right, and we saw some of these in our examples yesterday. So the main theme for today is that they aren't all circles, and we're doing intersections. Do you get if I had this one intersected with a circle, that my circle could go like this and I'd end up with 2 intersection points? Can you see that I could also have gotten 4 intersection points if I had put it somewhere else? Do you get a circle intersecting with that might go like that and end up having 4 intersection points? Okay, so it's about intersecting graphs today, and the graphs for polars are not always circles. Sometimes they're cardioids, sometimes they're limicons, all kinds of interesting names for them. I don't want to do the whole thing, but I want to do a couple. Let's make this theta first, and then an r. Let's pick a few angles. Let's do pi over 4. And let's do pi over 2. And let's do 3 pi over 2. If I were you, I'd make one of these dudes. Amara Johnson, did you have success on any of those 3?
No, I'm still writing them in.
Okay.
Gotten them yet.
That's all right.
Give me a sec.
No problem. Evan Olson, were you able to figure out any of the 3?
I'm still figuring it out.
Okay. I'm going to call on you 2 in a bit. Adele Adams,
Yes.
pi over 4. Did you try that one?
I actually went backwards.
Oh, okay. That's fine. Let's start with that. How did you do 3 pi over 2? I'm guessing you went here?
Yes, I did.
And then what?
The cosine of that is 0.
So if the cosine of that is 0, then I put a 0 here. Now what?
And then 3 times 0 is just 0, and then 3 minus 0 is 3.
Put your hand virtual or real up if you had 3 pi over 2 comma 3. Okay, good job. Bilderbeek, can you do pi over 2? Talk me through how you do pi over 2. So cosine of pi over 2 is 0 right here. Now what? If this goes in as a 0, oh yeah, it's going to be the same exact thing. So it's 3 again. All right. Olson, that pi over 4, if I was going to draw that, I would draw pi over 4 is like a 45-degree angle. It'd be like that. Tell me how to find the cosine of that. Evan Olson, are you here? Evan, don't be afraid to answer. I can give you credit for being here if you just say something. Are you here? All right. I will mark Evan Olson absent then. Evan, if you want to chime in and say something, that would be good. Okay. So Evan, no, we cannot hear you. I'd like you to exit and come back in. That should fix your mic. And if you're on something other than an iPad, I'd bust out your iPad. All right, I'm going to go to somebody else for this question. We're just asking you to pi over 4. Not an incredibly hard one or anything. So let's see. Elizabeth Del Monte, can you tell me how to put in the pi over 4 in the cosine here?
Well, the cosine is 1 over square root 2.
All right. So cosine of pi over 4. Here's where pi over 4 is, drawing a picture. 1, 1, square root of 2, and this is the 45-degree angle. Okay, we're good so far, and you said it was 1 over root 2. So that goes here. So now we've got 3 minus 3 times pi over, times 1 over root 2. Now I'll admit, it'd be really nice if you had a calculator at this point, but you aren't going to have one. So this is the part where if you didn't memorize what the square root of 2 was, you'd be toast. But I did. It's 1.4. So then this is 3 minus 3 times 1.4. Wouldn't it be really nice if that was 1.5? 3 divided by, sorry, there should be a divide by in there. It would be really nice if this was 1.5. So I'm going to cheat and make it 1.5. Because 3 over 1.5 would be exactly 2, wouldn't it? Isn't this really close to that? Can you do that? Yeah, if you're only 0.1 away, that's close enough. That's like rounding. We're just trying to get close. It's going to be a dot on the screen. It doesn't have to be super hyper accurate. So then this is about 2. 3 minus 2 gives you 1. It's pretty much 1. Now, if I wanted to graph these three things, pi over 4, comma 1, I put a dot right there. Pi over 2, comma 3, 1, 2, 3, I put a dot right there. 3 pi over 2, comma 3, and that's down here. Boy, that is not enough to really know what's going on here. And if I had to guess, though, here's an experienced guess. Why did I think it was that shape? Did you see it? A number minus something in front of the cosine. Cosines are generally on the right. That makes a cardioid, basically the heart shape. That's my best guess. So how would I know for sure? Well, I might try like 7 pi over 8. You know, because that'll shoot out this way. And that'll tell me if I have like a point that's kind of like right about here-ish, I'll be like, yay, I was guessing right. So everybody please figure out 3 minus 3 times the cosine of 7 pi over 8, which I would go and do circle trig on. It's out here. It's really 7 pi over 8. What should it be? It's not 7 pi over 8. I apologize. It totally blew past me. If these are pi over 6s, it'd be 11 pi over 6. Sorry. Nobody does pi over 8. Why did you stop me? Friend was in the driver's seat. They're just texting away, driving down the highway. What would you say? Would you have the guts to tell your friend, hey, put the phone down? Would you agree it's probably more likely they're going to do that than like break out a beer and start drinking and driving at the same time? That would be so obnoxious. You'd be like, hey, don't do that. You're going to get arrested. Might get us killed. Same thing with texting now. I hope you have the guts to tell your friend that. Or your teacher when they're going off track. Okay, so anyway, cosine 11 pi over 6. I got to draw it. I'll do way better if I draw it. This is 30. Cosine is, okay, so then if it's a 30, 60, 90, 1, 2, square root of 3. Oh, there's a negative one here. Negative right there. Okay, now, what's the cosine of that? Adjacent over hypotenuse, root 3 over 2. This part right here is root 3 over 2. 3 minus 3 times root 3 over 2. That's gross. What's root 3? It's about 1.7. 1.7 over 2? Isn't that pretty much just 2 over 2? That's pretty close to 2 over 2. If it was 2 over 2, then this would just be 1, and then it'd be 3 minus 3. It's a little more than that, though. So it'd be like negative, well, point something. It's really small. Hey, I wanted it to be really small. See, remember this point I was expecting to be really small right there? All right. Next. This is more like a typical, normal problem from this unit that's on your next test. Pay attention. If you've only got one problem left in you, let it be this one. Okay? Now there's 2 ways that I could solve this thing. One, I could make a list of all the points that I know that are on each of them. By the way, this one would be super easy. I don't care what the angle is, but the r would be 2. You know how they're usually r comma theta? Know what this one looked like? 2, 2, 2, 2, 2, 2, 2, 2, 2, and every angle that goes with it. If you actually draw a picture of it, it looks like this. How about this r theta chart? Well, it doesn't have a 2 every time, but would it ever have a 2? Well, if these 2 intersect, then it'll probably have a 2 somewhere. But I don't know until I put in some angles. So here I'm going to put in angles. I'm going to put in 0. I'm going to put in pi over 4. That's the same as a 45. I'm going to put in pi over 2. I'm going to put in 3 pi over 2. And do you get, if I'm just hunting around hoping to find the spot where they touch each other, that's going to be a pain. Now, if you have a whole bunch of people in the room like this, I can ask, has anybody found one where the r ends up being 2? What did you get? She thinks 5 pi over 6 worked. I'm going to verify. 5 pi over 6. So I'm drawing a picture. Here's where 5 pi over 6 is. And it's a 30, 60, 90, 1, 2, square root of 3. This one's negative. And then I want to do sine of that and then double it. Sine is opposite over hypotenuse. Oh, it's 1/2. That's going to work nice. 1 minus 2 times 1/2 is 1 minus 1, which is 0. R equals 0. 0 comma 5 pi over 6. If it was negative 1/2, but there, it wouldn't be a negative 1. There it is. There it is. You're right. It'd be down here. So this side would be negative 1. And then it would be 7 pi over 6. So 7 pi over 6 does go with negative 1/2. And now I'm going to bring this down and go 1 minus 2 times sine of 7 pi over 6. And this part's negative 1/2. 1 minus 2 times negative 1/2. 1 minus, oh, 2 negatives make it plus 1, which is 2. Boom, finally. 2 comma 7 pi over 6. Now, that's the hard way. I hope that you noticed that was not super easy. If you always have a choice between the hard way and the easy way, pick the easy way. When you're solving math problems anyway. So here's the easy way. Ready? If r equals 2 and r equals that, then if r really is 2, you can put a 2 right there. And 2 will equal 1 minus 2 sine theta. And then you can solve it. I'm just going to bring that over where I have more space here. 2 equals 1 minus 2 sine theta. What just happened? Well, r was equal to 2, so we stuck it in there. We put a 2 right there. That used to be r, but now it's 2. So now I'm going to subtract 1, and I get 1 equals negative 2 sine theta. Divide by negative 2. Sine of theta equals negative 1/2. But I feel like there'd be 2 answers for that. Look at these. Aren't they pretty much 2 circles? Isn't it likely there's going to be 2 answers? When they overlap, it makes sense there should be 2 answers. So just because I'm going to get 2 answers here, that makes sense. I expected 2 answers. The original question was, find where the points where they intersect. Everybody use circle trig. Find the points where those 2 equations intersect. Well, you stick the one equation in the other and you solve it. Bilderbeek, do you know which quadrants we have to be in? Okay. That one's out because positive, everything's positive there and we want it to be negative. And this one's out because the sign's positive there. So then I agree this spot and this spot. And then sine is opposite over hypotenuse, and this one's got to be negative, and then this must be square root of 3, also negative. And this one's going to be square root of 3 and a 1. Negative 1, sorry, and a 2. And then my 2 answers are this one. And that's a 30-degree angle, also known as a pi over 6. 6 pi over 6 plus 1 is 7 pi over 6. Raise your hand if you had that one right. Raise your hand if you know why it's actually still wrong. It's not because there's another answer. The other answer is 11 pi over 6. But my point, if you write these, you're going to be like a lot of people, and you're going to be wrong. Samik. So what do you mean? What are you talking about? 2 comma. Because why? Because that is a point. They asked for points. They didn't ask for angles. They asked for points where they intersect. And 2 comma 7 pi over 6 and 2 comma 11 pi over 6 are the two spots where these two circles would touch. Actually, one's a cardioid and one's a circle. All right, I'm going to give you another one that I think will make sense to you. If I said r equals 4 and r equals negative 4 sine theta, where would those intersect? I don't expect you to just look up and go, oh, I know the answer. But at least I'd expect you to think, okay, I know these are circles. R equals 4 is like this. Sine, and it's got a 4 though. So I don't know, maybe because it's got a negative in it, maybe it's reflected down here or something, but we should, oh yeah, I bet you it's probably just going to be touching down here, maybe at one spot, like maybe the answer is like that or something. So I wouldn't be shocked if there was only one answer. But if you're going to do it the hard way, you're going to have to make a list of all the points that are on this one and all the points that are on that one and see where they overlap. Much smarter way. Kyle Murphy. Kyle Murphy. Thank you. Are you with us or are you doing something else? Okay. Just set the something else aside. Pay attention. This is really important. So I've got these two equations, and I'm going to try to figure out how to get the intersection point, and I just have to stick the one in the other like that. Sinekin, tell me what equation I should solve. And then what's the first step of solving it? And that cancels, and I have negative 1 equals sine theta. Now what? I agree, circle trig. Where is sine going to be negative? Okay, and then I got my triangles drawn here, and I'm going to get my answers. Sine is, wait a minute. Sine is negative 1 over 1. That's one of those weird ones. It's a quadrantal. Which angle do you think it is, Mr. Sinekin? I agree. 3 pi over 2 is the answer. Am I done? I'm really close. You got the final point, Owen? The original problem started here, hint, hint. What's the R? Yeah, 4 comma 3 pi over 2. It has to go through 4. The other circle only goes through 4. So the other one has to be intersecting at R is 4, and the angle we didn't know, but we figured it out. I could have told you since the start of the problem that the R would be 4 in my answer. So 4 comma 3 pi over 2. Who feels like they could have got that one without me? Awesome. Okay. Then you are basically understanding intersections. You take the one equation, you stick it in the other one. I'm just going to show you this as a comparable thing. If I said y equals 2x plus 8, and then I said y equals 10, do you get you could just stick this one in here and you could solve? You know what I mean? That's just called substitution. It's the same thing, it's just substitution in the polar world. All right, you've made it this far. Now all you have to do is you should do later 1 or 2 questions from the homework. These are long, so maybe just do one good graphing one. Get practice on that, because it's definitely, this intersection thing is something you have to know for the test. If we spend a whole day on it, of course it's on the test. And start the Schoology quiz right now. I want everybody to at least know where it is so you can start the Schoology quiz right now. It's called Polar Review. So everybody get in there. So far, I've got 12 people in there. Let's try to get it up to all of you. All right. Today was about intersections of polar graphs. There was an example one, and it came out to a point. Remember, these come out to a point. R comma theta. That's all I got for the video for today.